Good afternoon. Today we will see two problems which are from cable, that is 2023. So you can have this civil engineer technical hub. You can go to this channel and you can see engineering mechanics subject in playlist, and you can have more number of problems related with this engineering mechanics. So now we have this 2019 pattern, and question paper we have 2023 January. So determine the tension in each segment of the cable loaded and supported as shown in figure. Now these two supports are not at same level, and therefore we cannot get value of VA directly. Now we can find an angle, this angle. So this angle we have tan inverse of, if I will say theta, then I have this as theta equal to tan inverse of. So we have vertical distance as 7, horizontal we have 4. So tan inverse of 7 by 4. And we will get this value of theta as 60.26 degrees. So we have this 60.26. Now to find this, we have to take moment about D equal to 0. So we have two reactions. One reaction VA, which will be acting vertically upward at A, and VHA, which will be towards left. Already I explained this. We have tension in the cable. Component of this tension is towards right. So we should have reaction towards left at left support and towards right at right support. So moment at D equal to 0. So moment due to VA, we have VA into total distance, we have 4, 5, 9 and 3, 12. So we have VA into 12. Then due to HA, we have anti-clockwise and distance is 4 between A and D. So we have to take vertical distance between A and D. And we have this as 4 meters. So minus HA into 4. And then due to 50, we have minus 50 into 5 plus 3, 8, minus 100 into 3 equal to 0. And from this we will get first equation 12VA minus 4HA, and that is equal to 700. So this is equation number 1. Now we will consider the portion till B. Now in cable, we can take cut from any point, but it should not be at a joint, at A or at B or at C. We cannot take section at these joints. We have to take between the joints. So let us, we have taken this section. And then due to this, we are going to get, so this we have HA, then we have vertical, this will be VA, and then we have joint B, and force at joint B is 50 kilonewton, and then we have taken cut from here. Now we are going to take moment about B. So this tension TBC in the cable passes through B. So moment is 0. Moment of 50 is also 0. So we have moment of VA and moment of HA. So moment about B equal to 0. Section taken between B and C. Section between B and C. And then we have due to VA. So we have VA into distance between A and B horizontal is 4 meter. We have this 4 meter. And due to HA, we have 7 meter. So minus 7HA, and that is equal to 0. And as we will solve these two equations, so by solving these equations, so we have two unknowns. So 12 minus 4, 700, then 4 minus 7, 0. So we have value of VA from here 72.06 kilonewton. 06 kilonewton. And value of HA, this is equal to 41.18 kilonewton. So VA we have. So now we will go ahead. So here we will mark all these values. So we have VA. This is 72.06. And HA we have 41.18. So this is 41.18. So now we know this angle we have already calculated 60.26. Now we have tension in AB. So now we will consider joint A. So at joint A, we have this as 72.06. This is 41.18. We have this tension TAB. And angle made is 62.06. Now you can take any one. So let us, I will consider summation fx0 and then I will get TAB cos 62.06 and that is equal to 41.18. And from this we will get value of TAB equal to 41.18 divided by cos 60.26. 41.18 divided by cos 60.26. And it comes 83.01. So we have tension in this cable 83 kilonewtons. So TAB we have 83 kilonewtons. Now this angle is 60.26. So you can see in above figure, so it is 60.26 degrees. So now we have this tension 83 kilonewtons. Now we know this force HA equal to HD because we do not have any other horizontal force. Now we can find VD. So we have to take summation Fy equal to 0. That is of whole body. So we can have summation Fy equal to 0. So what we will get due to this? So we have vertical reaction at a 72.06 minus 50 minus 100 plus Vd equal to 0. And from this I will get Vd that is equal to 77.94 kilonewtons. So we have this value 77.94 kilonewtons. Now we can have this angle that is, I will say alpha. So we have alpha equal to tan inverse of vertical reaction Vd upon Hd. And Vd, tan inverse of Vd is 77.94 divided by 41.18. So we have tan inverse 77.94, 41.18. And this angle comes 62.15 degrees. I already mentioned your reaction at D will be along the cable. This will be RD under root of HD square plus VD square. So now knowing this, we can have cos. So this cable, so again tension we have, so TDC. So we have TDC cos of 62.15 equal to 41.18. From this we get value of TDC and that is equal to 88.15 kilonewtons. Check it. 41.18 divided by cos of 62.15. So 88.15 kilonewton. So now we can have this. Now we are interested to find in CB. Now this we got 88.15. Now we will consider joint C. Now we do not know angle of this. So now we have this will be 88.15 and angle we have 62.15. Now this angle we do not know. Let us we have beta, and this also we do not know, that we have TD, TCB, and we have 400 kilonewton. Now we can have summation fx0, and from this we will get minus TCB cos beta plus 88.15 cos 62.15 equal to 0. And we will get one equation TCB cos beta, and that is equal to 88.15 cos 62.15. Sorry, this will be horizontal reaction 41.18. This is equation 1. And second we will get Fy0, where we have TCB sin beta, then plus 88.15 sin 62.15 minus 100 equal to 0. And we will get from this TCB sin beta, and that is equal to 22.06. Then we can divide 2 by 1. So we have TCB sin beta divided by TCB cos beta. And then we will get it as tan beta, and that is equal to 22.06 divided by 41.18. And we will have, therefore, beta that is equal to 28.18 degree. So we have value of beta at this 28.18 degrees. So this value we have 28.18 degree. Now we have to use equation 1. So we have this equation, that is TCB sin of, TCB cos of 28.18 equal to 41.18. And solving this, we have value of TCB cos 28.18 is 46.72 kilonewton. So 46.72 kilonewton. So tension in this cable also we have 46.72 kilonewtons. And then we have forces in the, or tension in the cables in this way. Now we will go last problem. So determine tension in the cables. AC and AB needed to hold 20 kg ball in equilibrium. F is given 300 Newton. So now value of D is given. So we have D equal to 1 meter. So now if we will calculate this angle, so alpha, so we have alpha equal to tan inverse of 1 by 2. And from this we will get value of alpha 26.56 degrees. Then we have this total angle, I will say beta. And we have beta equal to tan inverse So we have to consider total this distance, which is 3.5 divided by 2. And then we have value of beta 51.34 degrees. Now we have to consider joint A, which is in equilibrium. So we will consider joint A. We will plot in next slide. So we have, this is one ball, we have downward 20 into 9.81. Then we have, this is given 300. So this angle we have 51.34. And the second angle we have 26 point. So this angle we have 26.560. Now this is TAB. And this is TAC. So joint we have A, just we will check it. Joint we have A, first we have AC, the second we have AB. Now we will write summation fx equal to 0. Then we have minus TAC cos 26.56 minus TAB cos 51.34 plus 300 equal to 0. And then we will have minus TAC cos 26.56 minus TAB cos 51.34 equal to minus 300. This is equation 1. And then another equation we have Fy equal to 0. So we have TAC sine 26.56 plus TAB sine 51.34 minus 20 into 9.81 equal to 0. And we will have equation TA sine 26.56 plus TAB sine 51.34, and that is equal to 20 into 9.81. Equation 2. So solving equations 1 and 2, we get TAB equal to 98.67 Newton and TAC equal to 266.49 Newton. So we have, these are the forces in cable AB and cable AC. Actually, we have tried first AC because by solving this, first value is of AC and we have second value that is of TB. So now in this way, you have to go to the problems of the cable. So now we will stop here only. Thank you.